I am Régine Vadrot. I am a recently retired person from Airbus, the aviation side of it. I've been working there for more than 34 years in many capacities and using a lot engineering simulator and training simulator because I was in charge of operational evaluation of all aircraft from 320 to 350. Since I retired, I thought that perhaps I could help, and I've been asked to support Lilium in their project. So I am acting as senior advisor to Lilium. And today, on those presentations, I am in fact acting as the representative of the industry-led task force that Dan Ducey has asked us to think about what FSTD for eVTOL and airship. So it's time, two different types of machines. Airships and eVTOL. Why together? Because, well, don't ask why, but because in any case, one of the reasons is that there are no current CSFSTD related to those vehicles. However, you still need to train pilots on the task. So when we say we need to train pilots on the task, we want to start talking first about what is available for training. And when we look at the big machine on the right side, the airship, there is already something in FCL with respect to training. So there is a type rating process for airships. But as far as VTOL is concerned, there is nothing yet. It's too new. So we have no aircrew. There is no type rating section, nor any Appendix 9 in the FCL. So the question is how to tackle pilot training pending the result of the ongoing rulemaking task 0 to 30. One of the ideas is to use what is the latest publication from EASA, from the NPA 2020-15. I think you got already a good lesson on FCS from Eric, so I'm not going to expand on that, but really, that's where we are going to start. You also have a very interesting presentation from Dan Ducey on the European Rotors EASA section, which will detail you everything about it. But one point I like it very much is better cutoff for new innovations. So when we talk about airships, it's perhaps not an innovation exactly because there is already something. However, as far as VTOL is concerned, it is one. So if we look at how we could do that in terms of training development, the suggested methodology that we are contemplating as for the new technology aircraft, let's put it this way, is to build upon what is existing, meaning the current Appendix 9. So we built a big matrix, for example, where we list everything from the current Appendix 9. We are also, during the certification process and the internal development process, we have human factor inputs. So we take them into account. And at the end of the day, we select what is going to be the applicable training task leading to the potential eVTOL Appendix 9. So that's the training side of it. Now, what we do with the FCS. So we take the NPA and we have reference for the airplane, for the section related to Appendix 9 airplane. For helicopter, currently, reference is on the Doc 90. I never know the number.
65.
Yes, thank you. I always mix up. But that's where you can find the reference. At the end of the day, you have to make your own mind for eVTOL or eventually for airship if you want to apply the same methodology. What's going to be the proposed FCS for the task? And here we talk about the eVTOL Appendix 9. So the airship people are also considering applying the same methodology, but coming their current into the same approach with FCS and doing the same kind of analysis. So once you have decided about that, I would like to show you 2 points that I believe, based on the Lilium design, as an example. We have been talking a lot about visual cue and motion vibration cue. So on the Lilium, you might have seen the photo on the start. You have what we call canard, and you have also floor chain windows. And when you want the complete fidelity of the pilot visual environment, I mean, the traditional dome is not necessarily going to make it. So the VR MR solution really looks great for this kind of design. And remember that we are going to take off vertically and land vertically. So it's the safety critical phase of flight where those canards, mainly on the Lilium, they are having flaps with engine that moves. And the pilot needs to see that because he's going to know where he's going to be in his liftoff. So those two are really safety related. For the motion side, where I had already comment on the motion this morning, but again, here we think that critical, again, takeoff and landing in crosswind condition, or we have seen when the machine would fly between buildings. So the idea is that from what we have identified so far, we believe a representativity, not full specific motion, could be good enough. Because what you have to bear in mind on those new devices, we are not going to go zero flight time training like the big airline. So it's going to be a blend, most probably, of in-aircraft and synthetic training. So if you have an extremely good visual with VR where you can have your full immersive environment coupled with a good representation in terms of the motion system, I think this will make the job. That's where the thinking is currently. So now, so we've talked about the analysis, the assignment of the FCS. In training development, you have also to consider what is coming from the aircraft manufacturer side, the USD. But when it's a brand new aircraft, in fact, you do all that together at once. From the training, you have now the selection of the FSTD that you are going to do based on the FCS that you have identified here. Once you have specified what kind of device you want, you need to qualify. And that's where comes the next step, where again here we are having some kind of issue. Because as you see, there is no CS. So the only path currently is to use special condition process, using as well the simulator validation data from the manufacturer. So again, here in the same presentation I mentioned before, you have the two key points from Dan Lucy that I fully support for why we need to use special condition. Only known solution to integrate the new technology in FSTD regulation. eVTOL are not covered. We need to find a way. Airships are not covered. We need to find a way. But that is linked to the aircraft. The other point is innovative technology for FSTD like VR, MR. So really, the special condition is the path to allow new technology, like, for example, with the VR for VR motion, being able to qualify and get training credit, but also for new aircraft technology to be able to cover, and we cannot apply the traditional tests that are currently published either in CSFSTD Alpha or helicopter. So we've been tasked, so all volocopter, Lilium hybrid air vehicles and flying wells, to work together and to find a solution. Because, as I mentioned, there is nothing to support, and we need that. We will have to find a way forward if we can find a compromise altogether, but most probably at the end of the day, because of the specific of each product, we will end up with a specific special condition for each of us. So how did we manage? These special conditions, this is just the reference of the text, but what I want to point out is that we can use CSFTD A or H. You have to use OSD, or you go to the special condition. Let me try to guide you to the special condition path approach and how we see it and how we are going to propose a solution to EASA. So you have a new aircraft type, whether it's an airship, an eVTOL, or eventually this could be used later on for any kind of aircraft type. Is the current CSFSTD airplane available and applicable? Yes, it is available. If it is applicable, then you would use what is in there. For the helicopter, if it's not applicable, you have to go for the helicopter. If you are a rotorcraft, that's for sure you are going to use this one. And then, if the answer is no, that's where starts the story of the special condition. So the special condition, you could so consider that maybe some of the requirements of the current available CSFSTD are applied. It may be a mix, for example, of helicopter or airplane. And if some of them are applicable, the next question would be here, the tolerances, for example, of the test that you have selected, whether it's from alpha or helicopter, are those tolerances valid for your aircraft? They may be, and if they are, yes, then you use the selected elements directly with the tolerances. If the requirement does not exist for your product, then you have to build something for it. And then you would have to justify and provide a rationale, and it has to come with support from the manufacturer, because only the manufacturer knows the product. If you have a test that fits, but only the tolerance part cannot work for your aircraft, then you can propose something new in terms of the tolerances that match with the behavior of your aircraft, but again, you have to justify. And everything that you propose has to be justified and, of course, agreed by the authority. So that's the principle of how we thought we could use and how we try to make it work, that we have used, in fact, the skeleton. We are going to propose a kind of a template, if you like. So you have a big list of everything, and you pick what is going to be applicable for you. And how we do that? We use the structure of what is published in CS FSTD issue 3 from the NPA, which has part A, B, C, and F. With this part, we have kept more or less as is. We have put more generic wording so it can be applicable to any aircraft. And we have added the definitions that are specific to VTOL, to aircraft, etc. So this part can be used by anyone. On this part, you have here qualification basis, and that starts to be difficult to say it's going to be common to everyone. So we have looked at it in the aircraft type dependent elements and the ones that are independent. So we call that special or common. And here you have the aircraft features, and here, in fact, it's more the environment. And we'll come back on that. I will show you a few elements. So again, this is work in progress, so this may change. I have to say that. So for the test part, the same principle. You have what is really going to be aircraft dependent, which are performance and landing quality, and what might be more bracket common, which is related to the environment. And here we have not yet tackled this part. It's going to be what we have to do before the end of the year. But the same principle apply. But we believe that here maybe we can find a compromise that works for all, because we are talking about phases of flight. So we could put every list of phase of flight from helicopter, from aeroplane, and others. And if you have a new phase of flight for you, you would add on to it. So that's basically the idea. If we come to this classification of feature in special and common for the general requirements, the so-called subpart B. So what is called special are all what is related to the aircraft side. And for each of them, you would have to provide a statement of compliance for the type, class, or group of aircraft being simulated. What we call common are related to sound cues on one side and environment on the other. Cues, globally, let's put it this way, and environment. So in fact, to be sure that we cover every configuration, we have voluntarily kept the complete list from the helicopter side. But we have made a different assignments for vibration cues and motion cues to keep some of the arrangements which were in the airplane only, and there was no notion of vibration. They now are moved in the vibration, so it's a bit reorganized, if you would like, but you would find everything adapted for this common skeleton. And what is important is this allow, in fact, by building a special condition, to introduce the new technology for the visual side or for the environment, where you had a presentation from CE explaining that wind simulation between the building is going to be key. That is the kind of thing that we will have to look slightly differently to what is looked today. So the way it's set up, we'll have provisions. So you would have, in fact, a shopping list of the tests coming from Alpha and helicopters, plus a line that says other, where under other, you may bring the dedicated tests that would be required because of your specific environment, because of your specific aircraft design whatsoever. So that's the way where we stand right now. For the QTG, or let's say subpart C part, the validation test and fidelity, the same principle would apply. And the idea is that you look at CSFSTDA. If it works, you pick this one. If it does not work, you look at H. It may work. You pick this one. If it does not work, you look at if a combination of both would work. If it does not work, then you go for setting up your new test, which could be an output of the OSD process from the work with the manufacturer, or you propose new tests, which could be a result of this ongoing activity at the NPA level. That's where we stand at this time, at this point in time. And again, it will be split in between aircraft dependent, special, and aircraft type independent, common. So in conclusion, because I think it's late, we have to conclude the day. The message is work is ongoing. We are trying to find a kind of a skeleton, a template that could be used by anyone. We have tried to make sure that the terminology can be also used by anyone. And we have defined it in between common and special. And you would build your special condition for your need. Of course, it will require a lot of effort to discuss, negotiate, find the right solution with the authority. But it is the only interim solution we found until such a time that there will be sufficient knowledge about all that, so that perhaps there could be standard tests into an FSTD, a CSFSTD. So Dan explained that the roadmap is moving toward the right, because they got a lot of comment on the NPA 2020-15. What we are trying to think about with EASA is the following. The working group will try to propose these works that are illustrated in the flowchart early next year. We hope to have a very good draft. We have done already most of half of the job. It is EASA intent to find a solution to make that public for comment for a period that will have to be determined, but perhaps for 1 month or I don't know. And after this public consultation and after consolidation, the idea currently would be to publish this kind of baseline template, skeleton, for use by the different applicants. Because to be honest, whether it's Volocopter, whether it's Lilium, you have heard that target for entry into service is around 24, 25, 26, and it's not going to be ready. So we have to have a solution before that. So that's why we have been enthusiastic working on it, because we need a solution. So hopefully what will happen is that each OEM will produce its own special condition in this time frame. And when there will be a number of them available and more knowledge gained with certification on those new technology aircraft, most probably at a point in time, there will be a standard. That's it. Thank you.